Good, how are you?
Good. So this is a strange week, huh? You have, there's tests all week and stuff?
Yeah.
Okay. So what are we doing tonight?
We had to practice a SAT test, so I just sent you pictures of it.
Okay. You had to practice a PSAT test?
Yeah, sorry, that's what I meant.
Well, that's okay. I mean, I have, incidentally, 4 or 5 SAT questions, test questions, tests on my computer. So anytime you want to practice SAT, I got tons of them.
Okay.
Okay? No different than this. And in fact, the SAT test is the same as the PSAT test. Really is not any different. You want to go to specific problems that you know you missed, or?
Definitely number, I think that's a 4.
Okay.
That one I had no clue.
Let me see if I can blow that up a little bit. Yeah, there we go. Okay, so it's an isosceles triangle, and BC is equal to 48.
Mm-hmm.
So that's 48. And that's the same as that. Then we have 2 right triangles that are formed by that. And let's see, the ratio of DE to DF is 5 to 7. DE to DF is 5 to 7. What is the length of DC? Well, let me think about this for a moment. What's true about those 2 triangles at the bottom?
They're right triangles?
Well, they are right triangles, but what about the relationship between the 2?
They're 30, 60.
Nope. Are they congruent? Do they look congruent?
No, they don't look congruent.
Okay, so the next thing to ask is, are they similar?
Yes.
Yeah, they are, because I have this angle B is equal to angle C, and the right angle is equal to the right angle, which means this angle here has to be the same as this angle here. In other words, once you prove 2 angles are the same, you've proved all 3 angles are the same. And all 3 angles makes them similar. So, what ratio can I determinant?
5 to 7.
Well, by that question, I mean, if this distance is x from, if dB is x, what is dC?
Would it be x2?
No, if the total base is 48, and I'm letting x be from B to D, what is from D to C equal to?
-48 x?
You got it. That's a big realization, I should say. The fact that you can figure that out is important. Now, let's look at the similar triangles. I know that DE to DF is 5/7. DE, those are both the same sides of, they are the proportional sides of similar triangles. So I can say 5 is to 7 as what?
X is to 48x?
Yeah. X is to 48 minus x. In other words, this side here is to this side as this side here is to this side because of the similar triangles. Well, we know that DE to DF is 5 to 7, so the same ratio has to exist there. Now, that's an equation with only one variable. We can solve for x. Once I solve for x, then I've answered the question pretty much. Well, DC is 48 minus x. So let's solve for x first. What's the next step?
Would you multiply 48 to get that to the other side?
Yeah, usually whenever you have a fraction equals another fraction, cross-multiplying is what you want to do.
Okay.
Okay, well, if I multiply 5 times that, I get 240 minus 5x. You see that?
Mm-hmm.
That's equal to 7x after cross-multiplication. Well, now 240 equals 12x. Well, how about that? They made it a nice round number. But what's the answer?
Wait, no. They're asking for D.
DC, which we labeled as 48 minus x.
So
You'd been better off if I'd have labeled it as x, but I labeled it 48 minus x. So what's x, or what's DC equal to?
28.
Correct. That's the answer. If you're dealing with geometry and SAT or ACT, it's almost certainly going to be similar triangles. They love similar triangles. So look for similar triangles. And the one thing you know about similar triangles is that the proportional sides, I don't mean to say proportional, the corresponding sides are proportional. Well, ED was corresponding to DF. They were both the long side of each of those triangles. And BD is corresponding to DC because they're both the hypotenuse of those triangles.
How do you do this in, like, within a minute or 30 seconds or whatever they give you?
You just have to get used to what you're looking for. Once you take a couple of these tests, you realize that the only way we're going to be able to answer this question is if they're similar triangles. So get used to dealing with similar triangles. And similar triangles always have ratios. The ratio of corresponding sides is the same, regardless of which side it is. Not that this is an easy question, it isn't. This would probably be a high degree of difficulty, but nonetheless, very doable. And in terms of answering your question, how do you do this in a minute? Well, that's the name of the game. I mean, you have to really be on top of your geometry game to do this in less than a minute. What else? Which other question did you miss? This is good, and it allows us to focus on the ones that you missed instead of all of them.
Oh, I missed number 5.
Okay? So, any word problem should be started the same. How should we start all word problems? And I mean all.
Find the variable.
Define the variables. You always do that by looking at the last sentence. What's our variable?
How many puzzles did Tina solve? The puzzles?
Hard puzzles. The number of hard puzzles. You have to be very specific. Okay? Well, if I'm going to create a variable for hard puzzles, then I need a variable for easy puzzles. The number of easy puzzles. Now, what equation can I write from the second sentence? Well, the second and the third sentence. I can come up with 2 equations.
30y
Right.
plus 60x equals 50.
Not 50. She earned 1,950 points.
Oh, so 1950.
What is a second? In other words, I can't do much with that because there's 2 variables and only 1 equation. So I'm going to need a second equation. What's my second equation? Read sentence number 3. Yes.
Y plus x equals 50.
Correct. Now I can solve it. And that's all. I mean, solving it is another matter, but what I'm looking for to solve it is 2 equations and 2 unknowns. How do I solve this system of equations?
You could do substitution or elimination.
Let's do elimination. Elimination, I have found, always is easier if both equations are in standard format, as these are. In other words, I don't have y equal 50 minus x. That's not what they gave me. They gave it to me in standard format. Y plus x equals 50. So let's use elimination to solve it. This is equation 1. This is equation 2. What do I have to do to use elimination?
You can multiply that by negative 30.
Correct. So we're going to change equation 2. Minus 30y minus 30x equals minus 1500. And that replaces equation 2. And now what can I do to eliminate a variable? Whoa.
You,
Okay, there we go. Sorry.
well, that takes care of the y's.
Well, only if you
Well, you add them.
add. Well, that's important because you can add or subtract equations.
How do you know when to add or subtract?
Well, if this was a plus 30y, I would want to subtract them, right?
Okay.
Because my purpose is to eliminate a variable. But you kind of took care of that by multiplying by minus 30 because you knew inside that it's easier to add equations than subtract. Right? So now let's add the two equations. What do we get?
0y plus 30x equals 450.
Now solve for x.
15.
Yeah, you should have a calculator in front of you. So what's y? Well, we don't even need y. Well, yes,
Because I could just play.
no,
Right?
x was the number of hard puzzles, right?
Oh, yeah.
That's it. We're done. 15 is the answer. In other words, most of the time, they're going to want you to solve for both variables. But in this particular case, they didn't. They only wanted you to solve for one variable, and we did. It's 15b. Notice that how easy the problem becomes if you started out by defining your variables. That's the most important part, always. And you can't just say X is hard puzzles and Y is easy puzzles. You have to say X is the number of hard puzzles. Because only if X is the number of hard puzzles do you get this equation. And in this equation, there's actually a couple of ways to do this problem. You don't have to do it as a two-variable problem. You could say, if you wanted, and I'm only going to bring this up, not to confuse you, but I could say 50 minus x is the number of easy puzzles, right? If I wanted to?
Mm-hmm.
Well, now that gives me a whole different equation. If 50 minus x is the number of easy puzzles, then I get 30 times 50 minus x plus 60 times x equals 1950. Now I only have one equation to solve and only one variable. And it's the variable I'm looking for, x, the number of hard puzzles. So you can think to yourself that a one-variable problem is much easier to solve than a two-variable problem, but not really, because it takes a certain amount of out-of-the-box thinking to realize that the number of easy puzzles has to be 50 minus x. In reality, we used a second equation. It just doesn't look like it. It's going to give you the same answer for x. If I solve this equation right here, I'm going to get x equals 15. It's just has more to do with which level of algebra you're on. If you're on Algebra 1, you do it as a one-variable problem. If you're on Algebra 2, you go ahead and do it as a two-variable problem. Just know that if you have two variables, you have to have two equations. Notice this second equation here. Well, that really gives me what the second variable is. It's 50 minus x. You understand?
Yeah.
And which method you use is totally up to you. It depends on how easy it is for you to come to the conclusion that the easy puzzles are 50 minus x. To me, it's actually a little bit easier to use a second variable and make that equal y, and then have a second equation, and then solve the system of equations. All right. Go ahead.
Just keep going.
Okay.
Honestly, I probably got all of these wrong.
Yep.
I don't really. These ones I got really confused on.
All right. This says if r and s are two solutions of the equation above and r is greater than s, which of the following value of r minus s? Well, the first thing we need to do is solve that equation. It's a quadratic. Let's solve it, and then we'll deal with all their other stuff. Factor. What goes here and here?
X.
No? If there was x there and there, then this would be x squared.
Oh, 2x and just x.
Yeah. That, and then always check to make sure that produces that first term. Because that first term only comes from this first term multiplied by that first term. Now, what are both signs, the second step in factoring?
They're negative and positive.
They're opposite. Well, in this case, I have to allow for this. Only because these coefficients are different. This is 2x, this is x. So plus minus is not necessarily the same as minus plus. Whenever these coefficients are different, you have to allow for both. Now, what factors of fifth, and we cannot even state any rules. That throws all of our rules out the window. In other words, where I used to say factors of 15 that subtract to the number 7, can't say that anymore. This is a second degree level quadratic to factor. And by that I mean it's harder. It's a lot harder. It's trial and error. What two factors should I start with for 15?
Well, if we just go down, there's 1 and 15.
1 and 15. What else are there?
3 and 5.
Yeah. Now, when I see 1 and 15, I cannot cut 15 in half. Can I cut it in thirds? Yes.
Yeah.
If I cut 15 in a third, I got to multiply 1 by 3. And now I can't do anything more. So that's the only other factors. And I'm going to tell you this, that in Colorado, your answer is almost always, I would say 95% of the time, going to be the two closest factors. Not 15 and 1. They're not very close together, but 5 and 3 are very close together. So I'm just going to randomly start there. Remember, it's a trial and error process. What does that produce for a middle number? And this is an extremely important part of the process, is figuring out whether that produces the correct middle term. Well, the insides multiply to 5x, the outsides multiply to minus 6x. That gives you minus x as a middle term. Well, that not only is the wrong sign, but it's the wrong number. If I were to move the 5 down to the negative sign and the 3 down to the positive sign, all I would produce is a positive x. So I know that's not the solution. So instead of moving the 5 down and the 3 down, let's switch them. Let's put the 3 there and the 5 there and see if that works. What's that give as a middle term?
3x and 10x, so negative 7x.
Ah, which gives us the right number, the wrong sign. That means that if I move the 3 down to the negative sign and the 5 down to the positive sign, that's going to work. Notice now I have negative 3x, positive 10x. Add those together, you get positive 7x. That's the correct sign. So we factored it correctly. Now, what are my solutions? Now that I know I factored it correctly, what are my solutions? Two solutions.
Negative 5 and plus 3 over 2.
Good. Now that we have our solutions, which the following, and r is greater than s, which one of these is r?
R is greater than S.
One of these is s, one of them is r.
3 over 2 is bigger than negative 5.
So that's r. And now finally to the last part of the problem, what is r minus s?
3 minus 5. It would be negative 3.5, so 3.5.
Well, I've made a mistake somewhere. Was it in the factoring? Let me think for a moment. No. Factoring is correct. X is equal to minus 5 and x is equal to positive 3 halves. So that's definitely the correct solution.
Let me see what the actual answer is.
Well, hold on a second. I'm sure I can figure this out. R is greater than S, so R has to be the 3 halves. S has to be the minus 5.
Oh, don't you add 5 to 3 over 2? Because it's minus and negative?
Yes. Very good. Thank you. So what's my solution now? What's 3 halves plus 5?
It's 13 over 2.
Correct. Because that's 10 halves. Those turn to plus, so I get 13 over 2. Which is another example of where I thought I did it correctly, but I came up with an answer that wasn't in the list. I must have made a mistake. So it's nice that they didn't put the wrong answer in there, because I would have chosen it. And that's kind of the way these tests are designed. If you make a common mistake, which I made, it doesn't put that answer on there. In other words, it gives you a chance to catch yourself. You know what I'm saying?
Mm-hmm.
I came up with minus 3.5. That wasn't on there, so gosh, I better rethink my problem. And you solved it. The problem I made was I did minus instead of minus a minus. Seven?
Sure.
Do you want to do 7?
Yeah.
Oh, I see. It's 8 o'clock. You good to go?
Yeah, I'm good.
All right. We've done a half an hour. I forgot.
No, that's fine.
We were only doing a half an hour. So, no, those are good. We did 3 extremely good problems that you need to be able to do. And so I can't think of 3 better problems to review than the ones we reviewed. They're all hard also. But, all right. Well,
Okay.
quick.
Well, thank you.
I will talk to you next time.
Okay, thanks.
All right. Bye-bye.